8M7 lesson 20, truncated cones and truncated pyramids are part of this lesson. So this is, you're going to use a technique that we've used in finding areas and volumes of other shapes and using subtraction to solve these types of problems. I'm going to show you some truncated cones and some truncated pyramids, and you're going to use your imagination to imagine this cone as an entire cone with a cone subtracted from it. And we're going to use that technique to find volumes of cones. So without, maybe you have a mental image of what I'm talking about, maybe you have no idea. So let's get right to it and see what I am talking about. Well, many shapes in this world, you need to know, might need to know how much water would go into this bucket. How much water? How much water goes in this bucket without actually filling it up with water? If I filled it up with water, how much would be in there? Well, how many cubic inches? How many cubic inches of water? Well, this isn't any shape that we've seen before, but in fact, it kind of is. And let's see what I'm talking about. Well, we have this circle here on top, and then we have this circle here on the bottom. And what I've done here is I've kind of turned it upside down. And let's see if we can make sense of how we might find the volume of the water in this bucket. Well, notice what they've done. One thing that the person has done, or what the book has done for you, is they've taken the radius of the top, and the radius of the top here is 10 inches, 10-inch radius. And on the bottom, it has a 4-inch radius. Okay, so this is just that bucket upside down. And so let's see if we can make sense of how we might find the volume of this. We don't have a formula for this, but maybe we do. So let me draw some lines for you. Now what do we have? What do we have here? Well, let me use a different color and let's see if we can show what we have. Look at what we have. We actually have an entire cone. Inside the orange, we have a cone whose volume, here, I'll draw it down here. The volume of the orange cone equals 1/3 of the base times the height. And as we know, the base is equal to pi r squared. So 1/3 pi r squared h. So that's our orange size. But now look, we could take, now what is this orange thing comprised of? This orange cone is comprised of two pieces, and I'll draw one in green. So it's comprised of this green cone. This is part one of the orange cone. And part two is this pail. So we can actually find the volume of this pail here. Let me make the pail, we'll just make that one be kind of light blue. So we'll call that part two. And that's the pail. So what we can say is part one plus part 2 equals the large part. That makes sense? So the large part, this is a cone, and part 1 is a cone. So if we can find the large part, the volume of the whole thing, and subtract off the smaller cone, we can get part 2, because the large minus part 1 equals the pail. Right? The volume of the whole minus the volume of the little thing equals what's left over. Now the key thing here is, how do we find out what's left over? Well, let's take our picture over here and let's make another copy of it and put it right here and see if we can make heads or tails of this. Well, what we have, the one thing that you maybe haven't figured out yet, but is totally true, is that we can actually figure out what this distance is from here to here. And the way that we're going to do that, then that takes us up to our larger cone, like this. And we're going to use some building blocks, and those are going to be, it's going to be similar triangles. That's going to be the key that helps us figure out what this piece here is. And if we can figure out that piece, then we can figure out the height of the entire cone, as well as just the height of the smaller cone. And then we can find the volume of the smaller cone, the volume of the larger cone, and then we can subtract them and then find the volume of the pail. So let's go ahead and do that math. I'm going to take, so here's, now that we have this picture built, I'm going to I just want you to focus in on just this part of the picture. This part, and this part. And what you'll notice is we actually have similar triangles. I'm going to draw it once more here on the side. Here's our similar triangles. This is a 4. This is a 10. And this piece right here is 8 from here to here. So our similar triangles are let's draw them in different colors just for fun. We'll do the first one. We'll keep it in green like we had before. So we have this green triangle, and then we have this bigger orange triangle. So what do we know? We know that the ratio. Well, the ratio of the small. Let's take this small triangle and put it on the side for a second. So we're just going to take this guy here and we're going to put it right here. And so we have 4, and we have this distance here, which we don't know, so we're going to call it x. And then we're going to take this orange piece here, and we're going to draw that one. Okay, and on this one, this is a 10, and then we have this little piece here. And we know that this is 8, but the whole thing is x plus 8, because this piece is x and this piece is 8. Right? So this whole height from, I'm going to show you, from here to here, that whole thing is x plus 8, because this piece is x, this piece is 8. Okay. So now we can draw our ratio. So this side, the ratio of this side to this side is the same as the ratio of this side to this side. So let's go ahead and draw that. So the ratio of, and we'll solve it in pink, give it a different number, different color. X is to x plus 8 as 4 is to 10. And we're going to use this strategy over and over again. Now to solve this, we just cross multiply and we get 10x equals 4x plus 32. So we get 6x equals 32. And so we get x is equal to 32 over 6, which is the same thing as 16 over 3. So x is 16 over 3. So our big triangle has a height of 8 plus 16 thirds. Okay, let me just get rid of this line here for a second, and we'll do our math right down in this little box here. So the big cone has a height of equal to 16 thirds, and then the small one has a height. Sorry, the big one is 16 thirds plus 8, and the little one has a height of just 16 thirds. So let's find if we find the volume of the large cone, subtract the small cone, we're going to get the volume of the pail. So 16 thirds plus 8 is equal to 40 thirds, if you do your math, because this is 24 thirds. So that's 40 thirds. So the volume is equal to 1/3 pi times 10 squared times the height, which is 40 over 3. If you multiply all that out, you get 9 on the bottom, and on top you get 100 times 40 is 4,000 pi over 9. So that's the volume of the large cone. The volume of the small cone is equal to 1/3 pi, r squared is 4 is 16, times h, which is 16 thirds. So that equals 16 times 16 is 256 pi over 9. So our final volume, our volume of the pail, is equal to 4,000 pi over 9 minus 256 pi over 9. And I'm going to pull out my calculator to subtract 4,000 minus 256, and I get 3,744 pi over 9. And I'll write that up here because it's easier to do. So I'll write 3,744 pi over 9 cubic inches. 3,744 divided by 9. Oh, that actually simplifies down to 416 pi inches cubed if you divide. So there's the answer to number 1. That's a lot of work, but it's going to get simpler after we do this a couple more times. Because I'm not going to have to do quite as much explanation. We'll be better down here at our ratios, and you're totally going to get it. So let's do this a second time here. Let's open up this guy here. And so now what we want to do is we want to find the volume of this upside down pail. How much water would fit into this guy? Well, we need to extend our cone here. And so there's our extended cone. And so we're going to say the big cone, and then we're going to subtract our small cone, and that's what's going to be left in our pail. But before we do that, we have to figure out how tall the whole pail is. So let's put our X here. And so now we have our little triangle, and our little triangle is X and 2. And our big triangle, the height is X plus 12. And down here we have 8. So we write our ratio of X to X plus 12 equals 2 over 8. Do our cross multiply. 8x equals 2x plus 24. So 6x equals 24. So x equals 4. So this is neatly a 4. This long side here, x over x plus 12, this is a 16. So the height of the big cone is 16. So our big cone is 1/3 pi r squared h. So that's 1/3 pi times h squared times 16, which is 1/3 of pi times 64 times 16. 64 times 16, as we all know, is 1,024. So the answer here is 1024 over 3 pi. The small cone is similarly 1/3 pi r squared h, which is 1/3 pi times 2 squared times h, which is 4, which we all know is 1/3 of pi times 16. So we subtract off 16 pi over 3. 1,024 minus 16 is 1008. 1008 pi over 3, which is equal to 336 pi centimeters cubed. Good. So you should be able to use that strategy when you're finding volumes of cubes. We've done volumes of truncated cones. And this is a strategy that you'll have to use on your homework a couple times. I mean, we could have called this homework help. It really is. Lay down a happy cat for that. All right, let's keep going. So this is exactly, this truncated cone, this is a truncated pyramid. And this is exactly the same as a truncated cone, just a little bit harder to draw. But it is exactly the same. We're going to subtract off this guy here, that top piece, and it's really exactly the same problem as before. So we're going to take our big pyramid minus our small pyramid, and that's going to equal this piece here. But before we can do that, we have to do our similar triangles. So let's draw our big triangle. Down here we have a 10. Here we have a 12. Here we have an X, and here we have a 2. Right? This height here is X. This whole height is X plus 12. It's 12 more than X. This part of the similar triangle is 2, and this larger piece down here of the similar triangle is 10. So let's draw our two triangles. X, 2. Our big triangle, this is X plus 12, and this is 10. So x is to x plus 12. X is to x plus 12. S2 is to 10. Cross multiply. 10x equals 2x plus 24. 8x equals 24. X equals 3. So this little piece here is 3. So our height of our small pyramid is 3. Height of our big pyramid is 3 plus 12, or 15. So our big pyramid is 1/3. Okay, so we have to find our base, right? The volume of a pyramid, you have to calculate your base. And our base here, if these are squares, is if it's 10 is halfway across, 20 is all the way across. So this base is 20 times 20. Similarly, this guy is 2 times 2 is 4 by 4. So our base of our big pyramid is 20 squared. We're finding 1/3 of base times height. Base is 20 times 20 times the height, which is 15, minus the small pyramid, which is 1/3 of base. The base is 4 times 4, because it's a square, times 3. That's our height. All right. 20 squared is 1/3 of 400. 20 squared is 400 times 15. 15 times 1/3 is 5 times 400 is 2,000. Minus 1/3 times 4 squared times 3 is just 4 squared, because 1/3 times 3 is 1 times 4 squared is 16. So 2,000 minus 16 is 1984. 1984, and our units are cubic centimeters. So that's the whole idea with truncated cones and truncated pyramids. This wasn't a super long lesson, but I think you get the idea. And again, it's just application of what we learned in the last lesson, plus a little trick in helping you figure out what those magic heights are in what those, in understanding the concept of this, the imaginary invisible pyramid or the imaginary cone that sits on top of a truncated cone or pyramid. Now, but before I leave you, I want to give you one last piece. This is homework help. There's a challenge problem. This is a challenge on your homework, and I'm not going to do it for you, but I want to give you one little set of lines that might help you solve this thing. Well, you don't know what this line here is, and if you knew what this line here was, you'd know how to solve this problem. But let me give you a little hint. I'm going to drop this line down here. And then I'm going to say, well, this is a rectangle, and so this is 0.5, and this is 1.2. And I'll leave it to you, knowing the Pythagorean theorem, to figure out, use the Pythagorean theorem. Think about the Pythagorean theorem, and maybe you can find out this little last piece over here and solve this problem. So I'm going to leave you with that, and I'll be back with you next lesson to solve, be in lesson 21, and we'll continue on with some of this geometry. I think we're going to be doing compound volume of cones and spheres and truncated objects and stuff, and it will be super cool and super fun. Happy cat, happy math. See you tomorrow.